Every day, pipelines transport oil, gas and water across continents and under oceans, the unseen lifelines of our modern world. But when one of these pipelines fails, the consequences ripple across industries, economies and nations. In 2022, the Nord Stream pipelines stretching across the Baltic Sea suffered catastrophic failures. The event captured global attention and speculation. Were the ruptures caused by deliberate explosions, or were they predictable outcomes of accelerated corrosion, a process long misunderstood and often underestimated? Section 2. The role of the scientific method. To answer these questions, we return to the scientific method, a timeless process of observation, experimentation and analysis. We begin by observing an event and asking the right questions. We research, we form hypotheses. We test those hypotheses through experiments. We analyse data, draw conclusions and communicate results transparently. At Cathodic Protection Network, we apply this exact methodology supported by an advanced computational tools, physical modelling and decades of accumulated expertise. The Pipeline Consul, our proprietary data analysis platform, processes field data using structured algorithms, transforming uncertainty into measurable, reproducible evidence. Computers at their core are nothing more than electronic adding machines that count from 0 to 1. Yet, through structured logic algorithms, we transform raw data into insight. With accurate input, uncertainty becomes certainty. The Alexander cell and CPN procedures are the missing bridge between theoretical assumptions and practical verification, turning guesswork into evidence. Section 2. Understanding the Nord Stream system. To understand the failure, we must first understand the structure of the whole system. The Nord Stream system comprises two projects, Nord Stream 1 and Nord Stream 2, each consisting of two parallel pipelines, 4 in total. Each steel pipe measures approximately 1.2 meters in diameter with 40 to 50 millimeter thick walls and weighs over 20 tons once coated with reinforced concrete. This concrete not only prevents floating but protects against anchors, currents and seabed impact. Despite their massive construction, in 2022 explosions were detected and 3 of the 4 pipelines were damaged. Nord Stream 1 had been in operation since 2012. Nord Stream 2, completed in 2021, never entered service due to political disputes. Ownership of these pipelines is distributed among several major corporations: Gazprom, Wintershall, DEA, ENGIE, and others, underlying the project's geopolitical importance. Section 3. Engineering reality versus speculation. Public speculation focused heavily on sabotage, on the idea of external explosions causing the rupture in the pipeline. Yet, the physical evidence tells a more complex story. When the failures occurred, gas was observed escaping outward from the pipeline, confirming that internal pressure exceeded the external pressure. This fact alone suggests that internal degradation of the metal, not external attack, could be the true cause. From a corrosion engineering perspective, accelerated corrosion can consume up to 17 pounds of steel per amp per year. Under certain straight current or electrolytic conditions, full wall penetration can occur within months. CPN's analysis suggests that stray current induced corrosion rather than external detonated explosion may have been the initiating mechanism of the failure. However, to verify this hypothesis rigorously, we require complete access to engineering data as followed. All as-built drawings and corrosion control specifications. Pressure records before and after the failure. Metallurgical compositions of the steel and the sacrificial anodes. Electrical grounding and isolation layouts. Geological and environmental surveys. Ownership, legal and operational documentation. Without these, public conclusions remain speculative. Section 4. Defining the nature of explosion. A crucial question arises: what is an explosion? Scientifically, an explosion is the rapid release of energy and gas resulting in a shock wave. Legally, the term refers to a chemical or mechanical reaction that functions through detonation. In the case of a corroded pipeline, when wall thickness integrity is lost, the pressurized gas inside violently escapes into the surrounding water, producing a burst that mimics the acoustic and visual signature of an explosion. This is a mechanical explosion, not a chemical one, a vital distinction. CPN's experimental demonstrations, such as the 3 nails experiment, confirm how stray electrical currents can accelerate corrosion and lead to such pressure-induced bursts. My personal observations and case studies. My understanding of this phenomenon is not theoretical. Before the national gas grid was built in the United Kingdom, I served as an industrial safety officer for William Press Pipeline Company. I witnessed controlled destruction testing of steel pipelines, 24-inch diameter, coal tar enamel coated, buried and then pressure tested to failure. When weakened sections ruptured, the results were identical to that we now observe in the Nord Stream instance. A violent release of energy splitting the metal and soil displacement. In the case of the Nord Stream pipeline, it is the seawater displacement. Later, as corrosion engineer ENGE 18 for Shell BP Nigeria, I investigated repeated leaks on flow lines through direct current and potential analysis. I proved the cause to be accelerated corrosion from stray current discharge. After implementing corrective measurements, those pipelines operated leak-free for 18 years. This can be confirmed by Shell's records. Similarly, similar findings were recorded on the export lines at Bonny Terminal and Fort Cardis, where corrosion was misattributed to sabotage. The role of data integrity and public perception. In today's world, every image, every video, and every headline shapes public perception. Yet photographs can be manipulated, videos edited, and data misrepresented. At CPN, we reject speculation. We rely on data, measurement, and repeatable experimentation. The CPN blockchain records all measurements immutably, ensuring that every data point is time-stamped, authenticated, and verifiable by any peer anywhere. This transforms investigation into science, and science into truth. Conclusion. The Nord Stream pipeline failures remain an international mystery, but one that science can solve. By applying the principles of electrochemistry, physics, and data verification, we can replace conjecture with measurable certainty. Our mission at Cathodic Protection Network is to advance this understanding through research, innovation, and education. Our findings are not only relevant to Nord Stream, they redefine how we understand pipeline safety, energy systems, and even the nature of energy itself. This investigation and the technologies behind it, the Alexander cell, DCVT surveys and the CPN blockchain represent a new era of applied science, one where truth is measurable, data is incorruptible, and corrosion no longer has to be invisible.